Assalamu alaikum. Chapter 6 Architecture Design. This is the last lecture, which is we are going to cover the last pattern, which it is pipe and filter architecture pattern, and then the application example, which is application architecture. Well, as we said, topics covered so far in this chapter, we cover the architecture design decision, the decision we have, in order, or the question we have in order to make a decision of what architectural design we are going to have. Then we went there and we went through the views, see how many views, all the perspective and the view points of the customer, and all the views we could look at the architecture from him. Then we come up with the architecture pattern. The first one, we talk about the model view controller, then the layered architecture, which is abstract machine. Then in the lecture before, we covered the repository architecture and the client server architecture. In this lecture, we are going to cover the last, which it is the fifth pattern we could use in our project: pipe and filter architecture and application architecture example. What is pipe and filter architecture? This architectural design pattern allow for stream processing in our project. Stream, function after function after function. Well, in this pattern, there are many components, which is represented in those function or program, which are referred to as a filter here. The filter we mean here is the program, is the function, the process we have. And the connectors between those filters that called the pipes. So it is an arc and oval actually. It's a pipe and filter. The filter is the program and the pipe is the arc, is the line between these programs. And the assumption that those programs, they run sequentially. So we're saying here, functional transformation process their inputs to product output. So we transform from process to process. The input, it goes as the output of one process, it goes as input of the previous one, and to the input as to the second one, the one that comes after it, and so forth until we reach the end of that process. Maybe referred to as a pipe and filter model, as in Unix shell. In Unix shell, you could really concatenate so many commands in one command. If you have a shell which it has, a command, and that command, the output of it as an input of the second command, you just go concatenate these, all of them in one line. So the output of the first one, it goes to as an input for the second. The output of the second, it goes as an input for the third, and so forth. Variants of this approach are very common when transformation are sequential. So if it is sequential, well, I think it is good to use this one. If your process, if there is a program, it creates something, and that something, it was an input for that, the one after it, and so forth, then we could go with this architecture. This is a batch sequential model, which is extensively used in data processing system. Not really suitable for interactive system. No, this man, it's not going to work for interactive system. This means you give the program or the component an input, then it will have a relay to you. They ask you for something, then you put back, you interact with the program back and forth, back and forth. Well, pipe and filter is a simple architecture style which connect a number of components that are process a stream of data. Each connect to the next component in the process pipeline via a pipe, the arc, the one. It's like, we start with a data source. It goes the pipe, then it goes to a filter, go to the program. In other words, the command, the parameter we give it to the first program, the program, which it is represented here as a filter, create an output. The output, it goes as an input for a second filter, which is another program. Again, create an output, and that output probably it's end up in a data sync as a report or whatever it is, or it goes as an input for the third filter, and so on. What is the description for this one? If we now go to description, they're saying the processing of the data in a system is organized so that each processing component filter is a discrete and carries out one type of data transformation. The data flow as a pipe from the component to another for processing. An example, we'll see it in 613 in the next slide. When commonly used in a data processing application, both batch and transformation based system, where inputs are processed in separate stages to generate related outputs. That output, it goes as an input for the one after it. Advantage, it's easy to understand. So it is easy and simple and support transformation reuse. Workflow style matches the structure of many business processes. Evolution by adding transformation is straightforward. I mean, it is easy to maintain it. If there is a change in the process, you could really put another filter in the middle of that sequence or at the end of it, and that filter, it will take the parameter which it comes from the one before it, and they create an output to goes to the second one. Can be implemented as either a sequential or concurrent system. Sequential or concurrent system, we could really implement that pipe and filter pattern. Disadvantage, the format for data transfer has to be agreed upon. This means the input you give me in the third filter, I have to know about it, because that one is created as an output in the second one. This means, the first filter, when it takes an input, create an output, it goes to the second one, the second process. So the second process, they have to agree on the parameter which it is really taken by the first one. So a format of data transfer has to be agreed upon between communicating transformation. Each transformation must parse its input and unparse its output to the agreed form, as we just took earlier. This increases system overhead and may means that it is impossible to reuse functional transformation that are incompatible with data structure. Well, if we look at this example of pipe and filter, there is a sequential process for invoice. So we read the invoices, we read the invoice database or whatever. We identify if that one is paid or it's not paid, that invoice. If it is paid, then we issue a receipt, and then we send the receipt, or we print the receipt and send it, to the client. If it is not paid, then you're gonna find out when that payment is due, and then you're gonna issue a reminder and send the reminder again to the customer. So it is sequential thing. It is sequential. It's gonna go be either or. After identification, the payment, if it is paid, it go away. If it doesn't pay it go the other way. Well, so but all these things, all the like read issued invoices, identify, issue receipt, they are sequential. They come one after the other. The input of the output of one, it goes on the second one. Well, application architectures. Application systems are designed to meet an organization needs. So application architecture is the process of defining the framework of an organization application solution against business requirement. It ensures that application landscape is scalable, reliable, and manageable. So, as business have much in common, their application system also tend to have a common architecture that reflect the application requirement. And because we don't want to reinvent the wheel every time we are going to create an architecture or a system, so we could really use one of those application already has been done with that domain. So a generic application architecture is an architecture for a type of software system that may be configured and adapted to create system that meets specific requirement. So we'll take this as a reference. We start with it and probably make a little change to fit our project by deleting some process, adding some process, whatever. So the application architecture is something already done, and we used to call it reference. It's like a blueprint done. It's like when you go and you want to build a house and you go to the engineer, the architect, so probably he could really right away pull a blueprint from the drawer of his office and show you that really you could use this or that, or in order not to start from scratch with it. So he gave you one already done, probably a few years ago, a few months ago, whatever, because it has in the same domain. With a little change, by adding a room there, by get rid of something there, by deleting, adding, whatever, in a few hours probably you could come up with architecture for your system. Well, what's the use of application architecture? We use it as starting point for architecture design. I mean, if we don't want to take it as is, probably we'll just take it, and then from there we could really change something, delete something, add something from there. And that's why I always talk about in ERD, entity relationship diagram, in architecture design. I believe you could go to the net and find out some architecture application there to cover the domain of your project. Even in the class project, you could do that. You could go to the net and get some application architecture from there, and you could add something to it. You delete something out, or you remove a process from there, you add a line from there, or whatever, until it fits, the requirement of your project. We could use it as a design checklist to see if really we done that or that, or all these kind of things are done. We don't forget any of the thing we supposed to do. As a way of organizing the work of the development team, we could actually take that architecture and cut it in pieces in order to develop it incrementally, or as a checkpoint for really our development team, as a means of assessing component for reuse. We could take each component, input of output, and we could assess it if we could reuse it somewhere else in our project or other. As a vocabulary for talking about application type, again, when you look at the application architecture, I believe you get some terminology there. You could use some of the vocabulary there, which would make you really intelligent to talk and negotiate about your application in your system. Well, we have here a few examples of those types, of architecture. Data processing application, which is a data-driven application that processes data in batches without explicit user intervention during the processing, which is probably like a pipe and filter. Transaction processing application, data-centered application that process user request and update information in a system database. TPS, we'll see this one as an example, the underscore that we're going to see two examples here, transaction processing application, and the fourth one, which is down there, the language processing system. Event processing system application, where system action depends on interpreting events from the system environment. like event and stimuli, event and response, the one really kind of like the microwave oven, the one we saw and the behavioral model. And the language processing system application where the user intention are specified in a formal language that is processed and interpreted by the system. The language processing system is like a compiler system, and then we're going to see this example shortly. Well, the two examples we are focusing here, and we're going to go through them. We focus here on transaction processing and language processing system. Transaction processing system like e-commerce system and reservation system. Language processing like a compiler and interpreters. Well, for transaction processing system, process user request for input from a database or request to update the database. Either a request to update or to retrieve something from database. From a user perspective, a transaction is any coherent sequence of operation that satisfy the goal you want. For example, find the time of flights from London to Paris. User make a synchronous request for service, which are then processed by transaction manager. So this is an example, or that's straightforward, and there is nothing really you can explain. Well, the structure of transaction processing application, it is really like a type and filter. The pipe and filter, which it is I/O processing, take the input output, then go to the application logic. What's the logic of it? Then transaction manager, and then the database. But the difference here, it goes in a sequence back and forth, between these database and transaction manager, and between transaction manager and application. But I mean, it goes, first thing we do the I/O processing, then application, then transfer manager, then a database. That's the one. Well, let's look at the software architecture of ATM system. For ATM system, if we're gonna go with the input, process, output, then we see what's going on here. In the input, the ATM machine is the one. The output, again, the same thing. The process, it go to the database. So the input, you get the customer account ID in the input. After we with the card, we validate the card, we select the service. So right away, you put the card, you get the ID, you validate the card if everything okay, and then you select the service. It depends on the service to go to the processing. You query the account from the database, then you update it. Then after that, it goes back to the ATM and print the detail, return a card, and dispense a cash. So this is the architecture for, like ATM system, all ATM system. So for information system architecture, I think probably it will resemble, or it will be used, the layer architecture as really the pattern which really we could use it here. Why? Because if you look at the layers, first of all, it's the user interface, which it is the screen, the input, the one you're gonna input the parameter, you're gonna just put them there. Then the user communication, then information retrieval, and then the database down there. Information system have a generic architecture that can be organized as a layered architecture. These are transaction-based information system, as interaction with these systems generally involve a database transaction. So the layer are the user interface, communication, information retrieval, and system data. Well, we represent the ATM, or that information system, in this architecture. It's like in a layer. The first layer at the top layer is the user interface, which it is like the view, which it is what really the input, output. And then underneath it, user communication, authentication, and authorization. If really you find that, that like a security, to find out if really this guy is authorized to perform that transaction. Underneath it, information retrieval and modification. You retrieve the logic here, which it is, you retrieve the database from the database down there, transaction management database, and modification to it, and then you create some information, whatever, which it goes back to the layer above it, and then down from the layer above it to the layer up there, it is in the user interface. Well, it's more of the same architecture for the mental health care patient management system. You are on the web browser, which it is the view. Then the login underneath it, role checking, form and menu manager, data validation, and the layer beneath it. Then after that, security management, patient information, data important, report, data import and re-export, and report generation down there, and the patient database in the inner layer. The inner layer. So again, we follow here is the abstract machine or layer architecture. Well, let's look at the e-commerce system. It's a web-based information system. Information and resource management system are now usually web-based system where the user interface are implemented with the browser. So the browser represents the user interface, the view list. For example, if you take e-commerce system, it's an internet-based resource management system that accepts electronic order, take from the view, the browser, the order of goods or services, and then arrange delivery for these goods or service to the customer. So take the parameter and then arrange the time of delivery. And in an e-commerce system, the application-specific layer include additional functionality. Functionality is to calculate how much, So you put all your elements in one shopping cart, in which user can place a number of items in that transaction. One transaction, you could really buy A, B, C, 1, 2, 3, etc. You put them in the cart, then you pay for them all together in a single transaction. So these systems are often implemented as multi-tier client-server architecture, which it is discussed in detail in chapter 18. The first tier, it is the web server, responsible for all user communication with the user interface implemented using the web browser, which it is the user interface. It's the view. It is the one you send it through in the your parameter, your order, and then you receive back if there is a receipt or anything. Application server is responsible for implementing application-specific logic, as well as information storage and retrieval request. Any logic, take all these items, calculate them, the price, blah, 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 and retrieve that from the database, find out how many items, the quantity, find out the price for each, do the calculation, all done in the application server layer. And the layer or the tier, the inner tier, it is the database server moves information to and from the database and handle transaction management. Well, the language processing system, it takes a high-level language and converted it into a binary language in various phases. A compiler is a program that converts high-level language to assembly language, to a machine language. There is a linker tool is used to link all the parts of the program together for execution, which is executable, which is the machine code. With the system accept a natural or artificial language as input and generate some other representation of it, as we said, machine code or assembly code. May include interpreter or linker to act on the instruction in the language that is being processed. Used in situation where the easiest way to solve a problem is to describe an algorithm or describe the system data. Metacase tool, it's a type of application software that provide you with the possibility to create one or more modeling methods, language or notation for use within the process of software development. Often the result is a modeling tool for that language. So meta case tools, process tool description, method rules, etc. and it generate tools. So the result is modeling tool for that language. So a tool for the language really you would process. Well, if we look at the architecture here for language processing system, well, we start with the source language, the source code. You send it to the translator, check the syntax, semantics, generate the code, whatever, and then it goes to the abstract machine code instruction. The machine code instruction, it goes to the interpreter, which it get the data and fetch it, the execute, calculate, do whatever with the processor, and then it comes the result. When we talk about interpreter, it's like, run and go, which it doesn't really keep the machine code or the object code, put them back as executable. So every time you want to run the program, you have to run it from the source code, not from the object code. Well, if you remember, we talked about this compiler component in the repository pattern. So this is the components of the lexical analyzer, symbol table, syntax analyzer, syntax tree, and more in the next slide. In the lexical analyzer, which take input language token and convert them to an internal form, which take the source code letter by letter, token by token. A symbol table which hold information about the names of entities, variable, class name, object, all these things. So a table, it has the keyword, we use them there. Syntax analyzer, which check the syntax of the language being translated. And syntax tree, which is an internal structure representing the program being compiled. The internal structure, the tree of it. If A, then great, whatever, that is the tree of the program we are talking about. And then another component is semantics analyzer that uses information from the syntax tree, the one we did, and the symbol table to check the semantics correctness of the input language text. Logic of it, semantics. And finally, the code generator that works the syntax tree and generate abstract machine codes. Well, if we look at the pipe and filter for compiler architecture, we could really handle it in a pipe and filter pattern. First of all, after we read the language or we read the source code, lexical analyzer, take them token by token. When they finish those, and come up with the symbol or whatever, they go check it if it is in the symbol table or not. Then check after that the syntactic analyzer, then semantic analyzer, or which it is go through the analysis phase of it, and then after that the code generator at the end. And every time with those 3 or 4 of them, they always check with the symbol table and the syntax tree. Well, this diagram we saw it before, in the repository as an example of repository architecture, and we said abstract, syntax tree, symbol table, output definition, grammar definition, all these are in the repository, and then the programs around it, code generator, optimizer, semantics, syntax, logical, printer, editor, whatever, all these around, that repository. So we could really use it here as a repository architecture for the language processing system, which it is the compiler. Well, we reached the end of that chapter, which it is the architecture design. So the key points here are the following. A software architecture is a description of how a software system is organized. Architectural design decision include decision and the type of application, the distribution of the system, the architecture styles to be used. Architectures may be documented from several different perspectives or views as conceptual view, logical view, process view, and development view. Architecture patterns are a means of reusing knowledge about generic system architecture. They describe the architecture, explain when it may be used, and describe its advantages and disadvantages. Then we talk about the model of application system architecture, help us understand and compare application, validate application system design, and assess large-scale component. And from this application architecture, we discussed two of them, transaction pricing system and language pricing system. Transaction pricing system are interactive systems that allow information in a database to be remotely accessed and modified by a number, and we probably in that one we used the layer architecture, the layer pattern, which is the abstract machine. And the language pricing system are used to translate text from one language into another and to carry out the instructions specified in the input language. They include a translator and an abstract machine that execute the generated language. And we saw in this example we used the pipe and filter and we used the repository. So in this case, what do we mean by that? I mean, is our project really, could we use one pattern? No. We could use probably one or more patterns. We could use in some of our system a repository, and the other part we could use client server. So it doesn't have to be one pattern. By now we finished chapter 6, which it is the architecture design, and then we'll go to chapter after that, chapter 7 or 8, I don't know which one. Thank you and see you later.